Welcome to Brain Vision.
In this example, we have a container holding 2 moles of gas, and we want to figure out what the temperature of the gas is if it has an internal energy equivalent to a bullet with mass 8 times 10 to the minus 3 kilogram moving at 770 meters per second. So the first thing to remember from mechanics would be that the kinetic energy of a moving mass is going to be 1/2 mv squared. And we also know that this is going to be equal to the internal energy of our gas here. And the internal energy of our gas, U, or E internal, something like that, whatever you like to call it, is going to be equal to our kinetic energy here, which is 1/2 mv squared. And we can also express the internal energy for a monoatomic ideal gas as 3/2 nRT. So if we just set both of those sides of the equation equal to each other, we'll have 3/2 nRT is equal to 1/2 mv squared. We can see that the halves will cancel right away. And then the variable we want to solve for is temperature. So we can divide both sides of this equation by 3nr to isolate temperature. So if we do that, we'll have mv squared over 3nr. And remember, this is the mass of the bullet, not the mass of the gas. Okay, so we have the mass of the bullet in kilograms. We have the velocity. We have the number of moles. And then everything else is just constant, right? So we should be able to just plug all these values in. And if we do that, we'll end up with a temperature of 95.1 Kelvin. So what we just figured out is that if we were to take all of the energy from a bullet traveling at 770 meters per second and somehow convert that all into thermal energy, into the internal energy of an ideal gas, we could heat up that gas all the way up to 95.1 degrees Kelvin.